Right, hello again, year 10. I'm just going to go through a few questions that were set on MathsWatch. And this question here was of a decagon, and it told us to work out its external angle. Right, very easy to do. All we have to know is that the sum of the external angles of any polygon sums to 360. So I'm just going to quickly draw the external angles. So here's our external angles. That one's really bad, and it's straight. Coming from each vertex, going straight. So if we sum up all of these external angles, we should get 360. Now a decagon has 10 external angles, I think. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, just quick check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, of course, 10-sided shape, 10 external angles, 10 internal angles. And since it's regular, each external angle is the same. So what we have to do is 360 degrees, because we know the sum of 360, and we just have to divide that by 10, and that gives us 36 degrees. So 36 degrees each external angle, so x must be 36. Next question was of a pentagon. Now it's a regular pentagon. Again, the external angles are going to be the same, but this time we've been told to work out x, which is inside, and it looks like a weird shape. Now, the thing is about this shape, since it's regular, each side is the same length. Now take a look at the triangle that's been put inside this pentagon. What kind of a triangle is this? Well, it's a isosceles triangle, and the base angles are these two angles, and they are both the same, x and x. All we have to do is find out one angle inside, which turns out to be the internal angle. Very lucky here, interior angle. Don't know why I called it internal. Interior angle, and then we just have to do a little bit of calculations with triangles to work out y-axis. So let's work out the interior angle. Well, to work out the interior angle, we can do the long method, which is n minus 2 times 180, and then divided by the number of sides. This takes a long time. But if we find out what the external angle is, then we can just take it away from 180 because it's a straight line. So external angle again, 360 divided by 5, which is 72 degrees. Now this here is going to be 72 degrees. So the interior is going to be 180 subtract 72 degrees, which is 108 degrees. So this here is 108 degrees. And again, we have to do 180. Okay, so we worked out that that's 108. Sorry, let's just go a little bit slower. That's 108. So if we got 180, subtract 108, we're left with the two x's, and all that we have to do then is just divide by 2. So 180, subtract 108, which leaves us with two x's, so that's 72. So we know that x plus x must be 72. So 2x is 72 degrees. So a single x we divide by 2 is 36 degrees. So x is 36, and this is also 36. Notice that these two angles sum up to 72. In fact, it works with any triangle. If we draw a triangle anywhere, this external angle here is the sum of these two internal angles, and we can do a quick proof of this. In fact, it'd be nice to do a quick proof. Let's call this x, let's call this y, and let's call this angle z. Now if we do 180 subtract z, it would give us this angle there. There's a straight line, take away z, and you're left with 180 subtract z. Now, 180 also subtract z from a triangle, 180 degrees inside a triangle, take away z, we're left with x and y, which is also equal to x plus y. So this angle here, which is 180 take away z, is also equal to x plus y. Just through the fact that 180 take away z, 180 take away z is equal to x plus y, is equal to x plus y. That was just a quick proof. Going to the next question in the MathsWatch. We have a regular hexagon and we're told to work out what angle x is. And to do this, all we have to do is think about this as six different triangles. Now this angle here, which is an interior angle, is been split into half, or it's been bisected. So basically it's going to be the same on each side, or each interior angle. If we know what this angle is, all we have to do is cut it in half to get what x is. So let's work out an interior angle. Again, start with the exterior, which is 360 degrees. Divide that by the number of sides, which is 1, 2, 3, 4, 5, 6. And that gives us 60 degrees. So an external angle is 60 degrees. Remember, it's a regular polygon, so we can do this. So the interior is 180 degrees. Subtract 60, which is 120 degrees. So this interior angle, we use red, this interior angle is 120 degrees. So each interior angle is going to be 120 degrees. And to work out x, all we have to do is bisect 120 degrees, or cut into two. So 120 degrees divided by 2 is 60 degrees. So each of these tiny angles is going to be 60 degrees. So x is equal to 60 degrees. And the final question. Now the final question is a regular pentagon with center O. No idea why they've done that, but it's nice to know that they care about the center O. Maybe they do care. Maybe that's a hint part of the question. We'll see. Right. We can work out what x is. Well, this looks as if it's bisected, but not 100% sure. They are definitely isosceles triangles, or maybe equilateral triangles. Again, we're not sure, but we can start to prove it. Since this is regular, we can kind of guess that these lengths are going to be the same. Because if you think about it, a regular shape means all lengths are the same, all angles are the same. So why not the ones that go from O? Why can't they be the same? They must be the same. And to work out x in this case, again, we can take a wild guess that this angle, this interior angle, is just going to be halved. Because it's regular. Everything regular means it's something like a machine. It's like halving, or divided by the number of sides, or something related to each other almost most of the time. So let's start working out what the interior angle is and see if our answer makes sense. Again, interior angle is going to be 360 degrees divided by number of sides, in this case pentagon, which is 5, and that's going to give us 72 degrees. So the exterior angle, sorry, is 72. Right, do you want to run here? Yeah, I've already done this here. So the interior is going to be 108. I don't need to explain again, because this question here, regular pentagon, is basically very similar to this one. So the interior is going to be 108, and if we halve that, so half of that, so 108 degrees divided by 2, that gives us 54 degrees, so each of these must be 54, otherwise it won't be regular and just won't make sense because it needs to be regular. So each of these is 54, that means x is also 54 degrees. Could we have done it in a different way? Yes, we could have done it in a different way. Should we try a different way? It would be a good idea to try a different way. This angle here, that's this angle O, so this is going to be a different method, method 2, let's call it M2. This stands for M method. And we've got 5 angles inside of this regular pentagon. Now remember, regular means every angle that you create, especially when it's center O, because it's very important that it's center O. These angles must be the same. So if we do 360 degrees, divide by 5, this gives us 72 degrees. So the angles over here are 72. Now this length is the same as that length because it's an isosceles triangle. So 180 subtract 72 is 108. And all we have to do is halve it to work out one angle because those angles are the same, so an isosceles triangle, which equals 54. I feel like there's deja vu moments going on. We've already done this. Yes, because, oh wow, this here, this calculation is literally the same as method 2, but it's starting at a different point. And it's 108 take away, wow, 72 to give you 54. No, it's 180 take away 72 to give you 108, then we divide by 2 to give you 54. Wow, both methods is exactly the same, just starting from a different one. This one was starting from the external, this one was starting from the inside. Very interesting. Okay, hope you've enjoyed this video, hopefully it was useful. If you have any other questions, you can find me at school tomorrow or on Thursday. Enjoy, bye.